Hey there. Had a little quick follow up from last night. Just wanted to finish up on this thought. And when I went out for my walk this morning, it dawned on me if I had to mention this. So A and B are independent, and we talked about this, but we didn't. I didn't like finish driving it home. If and only if the probability of B given A is equal to the probability of B alone. Okay. So we talked about this. We talked about for if it was independent, who was in prison or not, based on their ethnicity, it wouldn't matter. You'd go out looking at the population. It's this percent of this ethnicity. You go into prison to be exactly the same. It wouldn't matter whether you're in prison or not. You with me? If it was the disease, and you're looking at diseases, and Jesus, disease is just showing up all the time, and it's exactly the same whether you're active or not. Well, guess what? It's independent of your activeness. Therefore, it's not an STD, right? We talked about that. And so on and so on and so on. And I hinted at that, but I didn't finish pounding that thought home. I kept saying, listen, if it's 50-50 men and women, then when you look at what kind of cars they drive, it should be roughly 50-50 all the way across. Obviously, some anomalies. But if it was like 70-30 on one and 80-20 on another, that's way off, okay? Provided sample size is big enough. But yeah, there it is. And so, again, if you look at this formula right here, think about what this means. What this would mean is that probability of active and have STD divided by probability of active, the probability of active pieces would cancel off of that if they were independent. So, again, this is what it looks like when you do something stupid like dice. Okay, until land on boardwalk, I have to get a 2. OMG, gosh, I have to get a 2. Well, as you all know, that's a 1/6 times 1/6 situation. It's 1 in 36 chance of getting a 2 on the dice because you get 2 1s, right? Okay, roll the dice. Oh, but listen, the first dice lands. Dunk, 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 dunk. This is the side that matters, right? There it is. It landed with a 1. The other one's still tumbling around. In your mind, you're going, what is the probability that I get a 1 on the second dice? Given I got a 1 on the first dice. And the first part of you is saying, you moron, they're independent. But then the other part of you is going, well, let's see. I feel like it's 1 out of 6. That's right, I feel like it is. And then the other part of you is going, well, you ding-dong, of course it is. But watch. The probability of B given A in this situation is you got to get a 1/6 on the first dice and a 1/6 on the second dice. That is the probability of A and B happening. On the bottom, you had to get a 1/6. You had to get a 1 on the first dice, which is 1/6, which is the probability of A alone. And you're like, oh, cool. Wait, whoosh, whoosh. Look at that. It's equal to 1/6. My, that's the same as the probability of B alone. That is getting a 1 on the second dice all by itself. That's right. So again, in a situation like this with dice or whatever, I'm never going to do this because I know going into it that they're independent. You with me? They're 100% independent going into this. But when it's going to happen, when it's going to come up is with statistics, looking at statistics. That's the biggest place that's going to come up. One more thing we'll see later on when we get to conditional probabilities. Not conditional, sorry. When we get into continuous PDFs, which will be next chapter, actually. So we'll learn about the next chapter. I think it's the chapter that we start actually doing the math on it. We'll be doing some integrals. We'll be finding some marginal distributions. You're like, I don't know what a marginal is. That's okay. And so what we'll find is this. You'll have this joint PDF they will have given us, and then we will find the marginal of one of the variables, let's say x, and we'll find the marginal distribution of y, and we'll go like, son of a gun, did you know this? If this is equal to the product of the other two, what does that say? It says x and y are independent. If it's not that way, then they're not independent. And it really boils down to this exact same formula, and we'll hit it again when we get there. But in essence, look at what we said down here. The only way this is going to be, the only way for that to be true in that situation is if the only way for A and B to both happen is if it's the product of A times the product of B, if they're independent. It's the only way. You'll multiply them and they have their own distributions, and when you multiply them, you get the same as if you just did them individually. And so we'll come back to the same definition soon. So it'll kind of, this whole thing will just thread throughout the entire book. That's why I make a big deal about it.